Problem number 3 on our rational functions word problem set is about this girl, Melissa. She walks 3 miles to the house of a friend, and then she returns home on a bike. And she averages 4 miles per hour faster when she's cycling than when she's walking. And the total time for both of the trips together, that is the round trip, going to her friend's house and back, the total time is 2 hours. And we need to find her walking speed. We want to figure out how much, what her speed is when she's walking. So we know what we're trying to find, her walking speed. And we want to figure out, think a little bit about our units. And notice that we're definitely using miles here. It's 3 miles each way. And they also tell us that she's averaging 4 miles per hour faster when she's riding her bike. So we're going to use miles per hour here. There's no mixed units in this problem, just miles and hours, and that makes our lives a little easier. So again, we're doing a rational function word problem here in our problem journal. And we're trying to find the walking speed. And again, it's a rate, so I'm going to use R for my variable to represent that. And we're looking for that in miles per hour. So the relationship, it's just another rate problem here. So we're going to use R equals D over T because that's the speed equation, the rate of speed equation. And first, let's think about when she's walking. We know that when she's walking, she's going some rate R. That's the thing we're looking for. And we know that she's going 3 miles. That's the distance. And it takes her some amount of time, T. We don't know how much that is, but I might just call it T sub W. It's how much walking time she's doing. And then I'm going to think about the other half of this problem, which is when she's riding. And when she's riding, she's going 4 miles per hour faster. So her rate is the same as she was when she was walking, but 4 miles per hour faster. So R plus 4. Same distance, 3 miles. And the time is just going to be like the riding time, T sub R. And we don't know what that is. We don't know either of these two times, and we don't know this rate. But what we do know is that if I add up the times, I get it's a grand total of 2 hours. So there are 3 equations now and 3 unknowns. And the unknown that I really want to find is this R. So I'd like to eliminate all the T's out of this equation over here so that I can just have one equation in terms of R. So I'm going to use substitution, and I can solve each of these 2 equations for their respective times. So there's that one. And this one here, I can multiply both sides by T sub R and then divide by R plus 4, and I get this. So now that I know these the times in terms of R, I can just plug those into this relationship, and I get 3 over R plus 3 over R plus 4 equals 2. And that is my equation that relates all of this information, and after eliminating variables, we can solve this thing for R. So let's do it. First, I'm going to multiply through by R. And if I multiply this thing by R, I'm left with a 3 because the R's cancel. And if I multiply this thing by R, I get 3R over R plus 4. And if I multiply this 2 by R, I just get 2R. So that's the multiplicative property of identity, property of equality. And now I've eliminated one of these denominators. Now I can multiply everything by r plus 4. 3 times r plus 4 plus, and when I multiply this thing by r plus 4, the r's plus 4's cancel, and I'm left with 3r. And that equals 2r times r plus 4. So that is also the multiplicative property of equality. And you can see a quadratic equation shaping up here, I think. If you use the distributive property, we get 3r plus 12 plus 3r equals 2r squared plus 8r. And that's from the distributive property. So now I can move all the terms to one side using the subtractive or additive property of equality, and then I'll be able to have a quadratic that equals 0, and that's usually the way that I solve. So if I subtract these 3r's, or really these 6r's from here, I'll be left with 2r. So really, once I do this, and I'm just going to rearrange my equation a little bit as I go, I get this relationship, and this is from the properties of equality. So this is a nice looking quadratic. I notice there is a common factor, so I can divide everything in this equation by 2, and I get r squared plus r minus 6 equals 0, and that's from the division property of equality. And you may have noticed already that I can factor this. I get r plus 3 times r minus 2, and that equals 0. And so I can, this is factoring. And then I can use the zero product property to go take the next step in this problem. That's the zero product property. And then using the properties of equality, I can solve each of these little equations, and I get r equals negative 3 or r equals 2. And I know that in my original model here, I was just considering positive rates and positive distances and positive times. And so I know that my solution is this positive value, r equals 2 miles per hour. That's how fast she walks.